You read the title, you know what day it is. It's the first day of spring break. So with midterms being all done, I think we could all agree that I just need more quantum. No, but I am going to use this time to catch up on some senior thesis stuff. I mean, I don't think it's too crazy to want to work during spring break because at least I get to do it on my own time. And the thing is that I met with a professor to talk about my senior thesis, and I was just like, yeah, let me know, because this professor is like super well versed in Python. So I asked him to look over my code and see if there was anything that was glaringly stupid that I was doing. And I said that, I tested my code for other cases. It looked fine. But mine was a little bit peculiar just because the potential that I'm subjecting the Schrodinger equation to sort of goes as 1 over r, which means that it's difficult to approximate it at the origin, because obviously it blows up. 1 over 0 goes to infinity. I was like, I'm having a hard time approximating it at x equals 0 because it blows up there. And he goes, don't start at x equals 0 then. For some reason that didn't even come to my mind. He was like, no, you're right. The universe, nature doesn't give a shit whether you start at 0 or whatever. Nature always works. But if you're trying to write a code to describe it, you've got to learn how to play the game a little bit better. So I'm going to adjust my code to just start a little bit after so that nothing blows up and I don't have to approximate infinity. And then the next goal is to automate the code because I've been having to do a lot of stuff by hand afterwards, which is just not necessary. Let me show you what I mean. Well, right now what my code is doing is it's solving what this should be numerically. This is just my wave function. And what I need to do after it solves this is plug the wave function into this equation here, and then I need to take this value that it calculates and substitute it into this equation here. So what this is doing is it's calculating the phase shift of my wave function for different angular momenta. So right now what my thing is doing is it's just calculating the wave function, and then I've been doing this step and this step by hand, which is just not very efficient. So the next thing that I want to do, the thing that I want to accomplish today, is automate the code to do all that stuff for me. And then just for reference, this J sub L is just the spherical Bessel function, and this is the Newman function. And as for the whole code thing with my professor helping, yeah, that was a really stupid mistake for me to do, or it was a really stupid thing for me not to pick up on. I'm more so just glad that it was a little stupid mistake like that and not a fundamental misunderstanding of A, the physics, and 2, how to implement the algorithm. But what I'm also going to do, that way I don't drive myself insane just doing one thing, is, every now and then I just decided to pick up this book. It's a tensor calculus for physics book, and this book is amazing. Like, this guy, Dwight Neuenschwander, just walks through the motivation of tensor calculus. He defines tensors in such a way that just makes it a lot easier to understand. So normally when you talk about tensors, it's a little annoying because they first define tensors by how they transform. So you would say a tensor is something that transforms as a tensor. And if you're first learning about them, that can be really frustrating. But you can do the same thing with vectors. You can define vectors as how they transform. So maybe in the future I might go over some of the lessons of this book. That way no one watching actually has to buy the book. You can just watch me go through it. But I do want to restrain myself from doing too many of the math videos. I know that could be a little annoying for people watching. But with all that being said, I'm going to get started on writing my code again. So one of the things that I realized, or actually that my thesis advisor realized, is that the answers that I'm getting with my code are about 10 to 12% error from the experimental result, which is pretty well established. So it's definitely me being 10 to 12% wrong than the experimental one being wrong. And there's a few things that definitely are attributing to that error that I can identify right off the bat. One is the fact that like I said, I was approximating infinity, which is, you don't really do that. And 2 is that the code, the wave function that I'm solving for, I don't really have defined as a function in my code. What I have it doing is just establishing a for loop and iterating that for loop to implement Numerov method. That's the differential equation solver algorithm that I've been using. And what that means is that I can't really say evaluate the function at this point and then have it spit out an answer. So what I've been doing, which was a little dirty, is, or more crude I guess, is plotting out my answer and then eyeballing the value of the wave function at a specific x value. So the first thing that I'm doing now is, instead of doing that, I'm extracting the x value from the list that I'm storing them in. So I have a list, and I have a bunch of x values in that list. So the first term of the list is 0, the second term of the list is 0 plus my increment, and so on. So I don't know exactly when in my list is the x value that I'm searching for. So what I'm saying is, if in this list the x value is this, pull out the index, let me know what point that is. And then what I'm going to do is use that point to start going over the next steps that I showed you that I have to automate this code to start plugging stuff into. Sorry if that was a bad explanation, but that's really what I'm doing. I'm sure there's better ways to do this, but I mean, it's my way and it's working. So the next thing that I need to do is just start evaluating these following terms to see if I can eliminate all of this error that I've accumulated. Alright, and after amending my code so that it automated all this stuff, still coming out a little bit weird, and I'm getting a different answer now. So I'm just going to go over the derivation of the problem one more time just to make sure, well, to see what I'm doing wrong. So hopefully I can find something that's super wrong in my derivation earlier. That way I can start getting the right answer. Well, now it's looking like the more I dig into this code, the more stuff starts to be going wrong. And it's about 6 o'clock now. I've been going at this for longer than I meant to today, so I'm going to call it quits for the thesis stuff. I'll try again tomorrow, see what's going on. It's now, yeah, I fixed some stuff and that made it worse. So, but hey, all this is gonna make it so much more satisfying once I literally crack the code. Probably still figuratively, whatever. Try again tomorrow, get a fresh start, and I'm gonna attack it, I'm gonna get it, it's gonna be great, we're gonna get good results. Cool, break, see you next time.